Systems of three linear inequalities. Sometimes, a third inequality is added to the normal systems of two linear inequalities, producing a system of three linear inequalities. The simplest case is when the third inequality contains a single variable and acts as a third boundary line for the solution zone. In this way, we often obtain a closed figure, triangle, as a solution zone, formed by the 2x2 intercepts of the three lines, as shown in the example. Example 1. A. Identify the solution zone of the system of linear inequalities. We have the following shown on screen. B. Check whether points A, -3, 2, B, -1, 1, and C, 2, 0, belong to the solution zone of this system. C. Find the coordinates of graph's intercepts. Solution 1. A. First, we have to turn all inequalities in the form y em x plus n to identify the individual solution zones. Thus, for the first inequality, we have the following shown on screen. This means the solution zone of the inequality lies under its graph line. For the second inequality, we have the following shown on screen. This means the solution zone of the previous inequality lies above its graph line. As for the third inequality, it is not necessary to do any operation as it is clear that the solution zone lies on the right of the vertical line x equals 2, including the line itself. Therefore, based on the previous findings, we obtain the following figure. We have the following shown on screen. B. Now, we have to check whether points A, -3, 2, B, -1, 1, and C, 2, 0, belong to the solution zone of this system by substituting each point in the inequalities of the system, and see whether this substitution gives true inequalities or not. Thus, for point A, x equals -3 and y equals 2, we have the following shown on screen. Since not all inequalities are true for the coordinates of point A, this point does not belong to the solution set of this system of inequalities. For point B, -1, 1, where x equals -1 and y equals 1, we have the following shown on screen. Since all inequalities are true for the coordinates of point B, this point belongs to the solution set of this system of inequalities. Last, let's check whether point C, 2, 0, where x equals 2 and y equals 0 belongs to the solution zone of the given system of linear inequalities or not. We have the following shown on screen. Since not all inequalities are true for the coordinates of point C, this point does not belong to the solution set of this system of inequalities. C. To find the intercepts, i.e. the points that form the vertices of the triangle which includes the solution zone, we consider 2 by 2 the corresponding equations obtained by the three given inequalities. Thus, for the first vertex, we obtain the following system of linear equations. We have the following shown on screen. Let's eliminate the variable x by multiplying the first inequality by 2 and the second one by 3 and eventually add the two equations. We have the following shown on screen. We find the x-coordinate of the first vertex by substituting the above y-coordinate in any of the equations in the system, for example in the first. Thus, we have the following shown on screen. Therefore, one of the intercepts, the bottom left, has the coordinates 9/19, -4/19. Now, let's find the second intercept by solving the system. We have the following shown on screen. This system is solved easier by substituting x equals -2 in the first equation. This yield, we have the following shown on screen. Therefore, the second intercept, the top left one, is at -2, 7/2. Last, we find the third intercept by solving the linear system. We have the following shown on screen. Again, we solve this system by substituting x equals -2 in the first equation. Thus, we have the following shown on screen. Therefore, the third graph's intercept, the bottom left one, has the coordinates -2, -6/5. It is not always possible to obtain a closed region, like the triangle in the example, as a solution zone for a system of three linear inequalities. For example, if two of the linear inequalities are dependent, i.e. when they have parallel graphs, we obtain a zone that is limited in two or three directions but unlimited in the fourth, as the graphs form a figure where two parallel lines are intercepted by a third one. Let's consider an example to clarify this point. Example 2. Solve graphically the system of linear inequalities shown in the following on screen. B. Find the coordinates of the highest point of the solution set. Solution 2. A. We have to write the first inequalities in the form y m x plus n. Thus, for the first inequality, we have the following shown on screen. Hence, the solution set of this inequality alone consists of the region the graph. For the second inequality, we have the following shown on screen. Hence, the solution set of this inequality alone consists of the region previously shown in the graph including the graph line. The third inequality includes the region on the left of the graph without including the vertical line x equals 2. Hence, for the graphical solution to this system of inequalities, we have the following shown on screen. That is all for lesson 10.4.3. To continue this tutorial, please watch 10.4.4, Systems of Inequalities, where one inequality is quadratic and the other is linear. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.